Good morning, friends and dear students. It gives me immense pleasure to be here again for my course Flight Mechanics. I am in the process of problem solving. We have solved the problems related to the atmosphere. We have also solved the problems related to the cruise, climb. Now today I am going to discuss some problems related to the topic on maneuvering flight. Once we talk about the maneuvering flight, it is the flight in which there is acceleration. Most of the time in all the previous 4 modules, that is the introduction to flight mechanics, then cruise and the climb, we have assumed that the flight is unaccelerated. Flight do not have any acceleration, velocity is remain constant. But here onwards, it is module 3, which is the maneuvering flight. In this, we have the turning flight, we have the pull-up flights. So what is the turning flight? We have the steady coordinated turn. That word we have to very much write, that steady coordinated turn. In this, aircraft is turning in the XY plane. There is no vertical motion. Only in XY plane, your aircraft is turning. There is no vertical motion. So that is the steady coordinated turn. There is no change in the velocity. There is no change in, and also the center of gravity is acting always towards the earth. So these two, if we club it, then it is called the steady coordinated turn. Another motion is the vertical flight. It is pull up like this, then it is going up, and it is down. It is called the pull-up maneuver. So we have done already, we have solved some, we have done the derivations, and now we will be solving some equation related to this topic. So I will go. So we will do some numerical, and numerical number 1. The aircraft with mass of 4500 kg, wing area 19.5 meter square, is cruising at the sea level with a speed of 250 knot. Assuming that the lift curve slope CLA of the aircraft is 0.1 per degree and alpha 0 is equal to 0. Determine the aircraft angle of attack. For this flight condition, we have to find out alpha. If the pilot decides to turn with a 45 degree of bank angle while maintaining the same air speed, what is the aircraft angle of attack? So here, the first condition is the same as a cruise condition, but the second condition, it is not the cruise. Here we have to turn the aircraft in a steady coordinated way. So we have to find out, and we have to see that how we have to solve the problem. So I will start with A, and we have to find out aircraft angle of attack. Angle of attack. That is called alpha. So we know that the coefficient of lift CL is equal to 2W divided by rho V square S. And here it is W is equal to 4500 into 9.81 Newton. It is W is given, rho is the sea level 1.225, V is equal to 250 knots or 250 into 0.5144 meter per second, and area S is equal to 19.5. These things are given. So now I will put this value 2 into 4500 into 9.81 divided by 1.225 into V is equal to 250 into 0.5144 whole square into area is 19.5. So CL we are going to get as 0.22. Now we know the equation for A is equal to CL by alpha, or alpha is equal to CL by CL alpha. CL we got 0.22 and CL alpha is given 0.1. So degree. So per degree. So 0.1. So I will get this answer 2.2 degrees. So alpha, that is angle of attack. This is the answer for the problem number A. Now we have to see the problem number 2. So we will see the B. So in this case, bank angle is there. Bank angle phi is 45 degree. So again, CL is equal to same way 2W rho V square S cos of phi 2 into 4500 9.81 divided by 1.225 250 0.5144 whole square into area is 19.5 cos of 45 degree. So we will get CL is equal to 0.31. So from here we can get alpha is equal to CL by CL alpha. So 0.31 divided by 0.1, you will get 3.1 degree. So in this case, we got the angle of attack. If you are turning the flight, so what is the analysis? Analysis is that if we are flying at 45 degree turning, the angle of attack alpha will be 3.1 degree, which is much greater than the normal flight. So this is the conclusion for the result. Now I will talk about the numerical number 2 that we will be discussing. So I will read out this problem. Consider a very light aircraft with a mass of 750 kg and an airspeed of 100 knot. A. If the maximum permissible load factor is 3.8, what is the equivalent maximum bank angle for this load factor? So here the permissible load factor is 3. So we have to find out the bank angle. Next is determine the corresponding turn radius for a coordinated turn with a bank angle. If the aircraft is turning coordinately with a radius of 300 meters and a bank angle of 30 degree, calculate the air speed and the load factor. This we have to see. Now we have to solve this problem. Here, the first problem, if you see in the problem, we have bank angle. We have to find the bank angle. So here load factor is given, n is equal to 3.8 and find the phi. So we know that n is equal to 1 by cos phi. This is 3.8. So cos phi is equal to 1 by 3.8. So phi is equal to 75 degree. So this is the bank angle. Bank angle we got 75 degree. Now we have to go for the another problem. Problem number B. This is the problem number A of this. We have to find out the turn rate. So here we know that the radius is equal to V square by G under root n square minus 1. V square is V is equal to 100 knots, 0.5144 whole square divided by 9.8 into under root 3.8 square minus 1. So this radius we will get 72 meters. And we also know that load factor n is equal to, it is load factor n is equal to 1 by cos of phi. So for 30 degree, 1 by cos of 30, load factor n will be 1.154. So this is the load factor, and air speed, we have to find out the air speed from this equation. So we know that V is equal to under root R G again under root n square minus 1. So here we can write that R is equal to 300 into 9.81. Again under root 2 we will get 1.154 square minus 1. So we will get this result. Velocity is equal to 41.2 meter per second. So this is the turn rate velocity which we have got it. So this is the answer for the problem number 2. So now we will go for the problem number 3. Okay, we will see what is the problem number. So determine the stall speed of a utility aircraft with a mass of 4500 kg, a wing area of 19.5 meters square, and the maximum lift coefficient of 2.5. Perform this analysis at the sea level for the following two flight conditions. One is the cruising flight, another is the turning flight with a 30 degree of bank angle. So here some parameters are given. So here the mass is given, then area is given, and CL is given, and then coefficient of lift, 3 parameters are given here. So first we will see on the A, cruising flight. And we know that stall speed Vs is equal to under root 2 mg by rho s CL max. M is given 4500, 2 into 4500 into 9.81 divided by 1.225 into area is 19.5, CL max is 2.5. So we will get Vs is equal to 74.7 knots. So this is the stall speed of the aircraft for the cruise flight. Now we will discuss about another flight, that is the B. It is a turning flight. Turning flight, your phi is given as a 30 degree. Means your aircraft is turning like this with a 30 degree of this angle. So 30 degree is given here, and in this case the stall speed Vs is equal to 2 mg divided by rho s CL max into cos of phi. So 2 into 4500 into 9.81 divided by 1.225 into 19.5 into 2.5 into cos of 30 degree. So we will get Vs is equal to 41.32 meter per second, or this is 80 knot. So very well we can observe that at the cruising speed the stall speed is less than the cruising speed of during turning. Stall speed during the turning, and we can make it in the percentage. So stall speed in turning flight increases than the cruise flight, and nearly it is, I think, nearly 10% it is higher than the turning flight. So now okay, we will go for the numerical number 4. So this we will see it. So this I will be reading this problem. Consider the twin turbofan engine supersonic combat aircraft McDonnell Douglas, now Boeing FA-18 Hornet, with the following characteristics. M is equal to mass 16,770 kg, area is equal to 38 meter square, span is equal to 12.3 meter, thrust maximum is equal to 2 into 79.2 kilonewton. Assume the maximum allowable load factor is 10 and the alpha naught is equal to 0, CL alpha is equal to 5 meter per second per radian, E is equal to 0.83, CD naught is equal to 0.022, CD naught for the transonic is 0.032, CD naught for supersonic is 0.042. By the way, the mass is the aircraft loaded mass and the engine loaded mass and the engine thrust is with the afterburner. The maximum lift coefficient of the aircraft without using flap is 1.4. Will this fighter be able to turn coordinated level at the bank angle of 75 degree and a 1000 meter of turn radius at 10,000 feet? So this we have to see that whether this is able to do this bank angle or not as per the given condition. It takes, determine the time it takes to have completed 180 turns. Means full half turn it is tilted. Okay, so just we are going to solve. So the solution is to investigate the capability of the aircraft for this turn. We need to inspect the following 4 items. One is the desired load factor less than the maximum allowable load factor. So the desired load factor should be less than the allowable load factor. Is the desired load factor less than the maximum producible load factor? Is the turn air speed more than the turn stall speed? Does the aircraft generate a sufficient thrust for this turn? We first need to find out the following 2 parameters. So now we have to see that we have to find aspect ratio, which is B square by S. B is 12.3 square, it is given. Area is 38 meter square. You will get 3.98. K is equal to 1 by pi aspect ratio into E, 1 by 3.14 aspect ratio 3.98. E is given as 0.83. So the value of K we are going to get 0.096. Now at 10,000 feet, the air relative density is 0.738 and air density is 0.904 kg per meter cube from the table, from the ISA table. So now maximum engine thrust, max engine thrust is equal to T is equal to T naught rho by rho naught to power 1. T naught is 2 into 79.2 into 0.738. So this you will get here that 116.9 kilonewton. So this is the your, at that altitude we will have this much of thrust. So now we will see the first problem. First problem, desired load factor. Desired load factor, that is N is equal to 1 by cos of phi. So 1 by cos of 75 and 3.86. So the desired load factor is the desired load factor is less than 10, which is given. So it is accepted. So now I will go for the second item. In this, maximum producible load factor means Nmax. This Nmax is equal to, we know that Tmax divided by 2W under root K CD naught. So this is Tmax, we have just now find out 116.9 kilonewton divided by 2 into weight is 16,770, 9.81 into under root K we have find out 0.096 into CD naught is given 0.022. So we got Nmax is equal to 7.72. So now this, the desired load factor, the desired maximum load factor is less than the maximum producible load factor of 10. So it is acceptable. So and maximum is also acceptable. Now we have to find out the turn radius or the turn air speed. Turn air speed, we have to find out the V, and we know that R is equal to V square by G under root N square minus 1, or V is equal to under root RG under root N square minus 1. So if you see here, put this value V is equal to under root R is equal to 1000 meters, 9.81 G, again under root 2, 3.86 square minus 1. You will get this velocity 191.3 meter per second. So this is subsonic velocity. So CD naught of 0.022 is used in this. So we have to find out the stall speed in this case. So in this case, stall speed Vs is equal to 2 mg divided by rho s CL max cos of phi. So 2 into 16770 into 9.81 divided by 0.738, 1.225, 38, 1.4 into cos of 75. So Vs we are going to get 162.5 meter per second. So this Vs is less than V ton. So Vs it is V ton, we got 191.3 meter per second. So it is acceptable for given conditions. So this is the 1 point. Now we have to required thrust. We have to find out the required and we know that it is equal to the drag, and we know that drag is equal to half rho V square S CD naught plus K into 2N W by rho V square S square. So we have to put this value half into 0.904 into 191.3 square V square into area 38, CD naught 0.022 plus 0.096, 2 into 3.86 into W is equal to 16670 into 9.81 divided by 0.904, then V square is 191.3 square into area is 38 whole square. So now we will get this drag is equal to 75696 Newton or 75.7 kilonewton. So, and this is equal to thrust. So this thrust is equal to thrust R is equal to 75.7 kilonewton. So this is the another answer. So now we have to find out the aircraft angle of attack. So I will take some another color. So angle of attack, we know that CL alpha is equal to DCL by D alpha. So alpha is equal to CL by CL alpha. CL is 1.011 and CL is equal to 511.6 degree. So we got this is the angle which we have got. So we have solved all the topics for this. Now we will go for the next problem, number 5. So just I am reading this problem. Consider the single engine turboprop utility aircraft Cessna 208 Carvan with following features: MTO is equal to 3995 kg, S is equal to 25.9 meter square, P is equal to 647 kilowatt, B is equal to 15.88, Vs. These all parameters are given. Determine the corner speed of the aircraft. Then determine the corresponding load factor, turn rate and the turn radius. What is the maximum producible load factor in a level turn? Then determine its corresponding air speeds and the bank angle. Third one, assume the aircraft is turning with an airspeed from a corner speed to a maximum speed. Plot the variation of load factor, bank angle, turn rate and the turn radius. Assume the sea level, constant propeller efficiency and the constant zero lift drag coefficient. So these are the, so we have to solve this problem. So we have to first find out the aspect ratio for, and it is a B square by S. B is 15.88 square, area is 25.9, you will get 9.74. Kappa is equal to 1 by pi, aspect ratio E, 1 by 3.14, aspect ratio is 9.74, E is 0.9, 0.3, 0.0, we are getting 0.036. L by D ratio, L by D max, we know that it is 1 by 2 under root K CD naught. 1 by 2, we know that K 0.036 into CD naught, we got 0.038, it is given, so we got 13.5. So we have to start now with given, first we have to find the corner speed and corresponding load factor, turn rate and radius. These things we have to find out. So I will start with first corner velocity. It is called V star and we know that it is 2 P max eta P divided by rho S CD naught plus KCL square max. 2 into P max 647,000 into 0.85 divided by 1.225 into 25.9 into 0.38 plus 0.038 plus 0.036 into 2.51 whole square, and you will get this velocity, that is the V star, 50.7 meter per second or 98.5 knot. So this we got the velocity. Now we have to see here the corresponding load factor. We know that N max is equal to rho V star square S CL max divided by 2W. So here 1.225 into 50.7 square into S is equal to 25.9 and 2.51 divided by 2 into 3995 into 9.81. We will get N max is equal to 2.61. So this is the maximum load factor which we have got it. Now I will go for the next corresponding turn rate, that is omega max, and we know that it is g under root n square minus 1 v star 9.81 2.61 square minus 1 divided by 50.7. So omega max you will get 0.466 radian per second. So this is the another answer, or we can write it as a 26.7 degree per second. This is the in the degrees. So we got this problem. Now we will see the next, that is corresponding turn radius, that is R minimum, and we know that R minimum is equal to V star square divided by G under root n square max minus 1. So 50.7 divided by 9.81, 2.61 square minus 1, R minimum you will get 108.7 meters. This is the minimum radius required for. So for the part 1 we have solved all the problem. Now we have to go for the part 2. In part 2 we have to see the maximum producible load factor, and this is n max is equal to 0.687 rho np square p max square s L by d max divided by k into w cube 1 by 3. This is the equation, and we have to put all the values. We have 0.687, 1.225, it is 0.85 square into P maximum is 647,000 square into 25.9 into 13.5 divided by 0.036 into 3995 into 9.81 cube, it is a cube, and root 1 by 3. So n max you will get 2.68. So this is also the another answer, n max. And what is the air speed in this case? Air speed that is V max is equal to P max and P divided by 2 rho S CD naught power 1 by 3, and you put this value P max 647,000 into 0.85 divided by 2 into 1.225, S is equal to 25.9, 0.038 to the power 1 by 3. So you will get here V max is equal to 61.3 meter per second or 119.3 knot. So this is the another. And how much is the bank angle? Bank angle phi max is equal to cos inverse 1 by n max. So 1 by 2.68 you will get 68.1 degree. So this is the maximum bank angle 68.1. Okay, so this is the answer, and this is here the plots variation of load factor, turn rate, bank angle, and turn radius versus airspeed. Different plots are shown here. And for my next lecture, we will be discussing about load factors, compare the velocities, determine horizontal distance and the rate of climb, plot VN diagram. These are the references: Anderson JD, Aircraft Performance and Design, International Edition Micra Hills, else by Aircraft Performance Theory and Practice AIAA series. Thank you very much for joining. Please be tuned for my next lecture. Goodbye.
Like, share and subscribe. Hit the bell icon for more updates.